Hello, everyone. As Emil said, I'm Phil Levy. I'm the CTO for Neurologics. We're a Canadian company. And as you can tell from the title of my presentation today, how Affective AI is revolutionizing HealthTech and Insurtech. So I'm here to talk about this, to explain to everyone just exactly what it is that we do. We are obviously not an insurer, we're not an insurance provider or broker. Instead, we've developed some technology that we've had it's been very synergistic application in the insurance market space. So I'm here to talk about that and really answer any questions or hopefully explain to you what it is that we do and how you might use this. All right, so the first thing I need to address is just what exactly is Affective AI? Well, Affective AI refers to the intersection between affective computing and artificial intelligence. The intersection, right, where they join. Affective computing and artificial intelligence. Now, this powerful combination provides the ability to recognize, measure, predict, and simulate human affects that take the form of physiological and psychological states through the application of machine learning models, in our case. So I know what you're saying. You're saying, what was that? What did I just say? That was a lot of words. What does it mean? That's really what I'm going to try and do here today, is to explain this, to break it down, and hopefully you will leave with a much better grasp and understanding of Affective AI and how that might be applied. Neurologics is a preeminent pioneer of Affective AI. We are the source. So you're hearing it right from the horse's mouth in terms of what this is. So if we go back to that first bullet, the intersection between affective computing and artificial intelligence. So effective computing you can simply think of this as any system that has the ability to process and analyze human affects. That's it, the ability to process and analyze human affects. And we will talk much more about what those human affects are. How do we process and analyze human affects? At Neurologics, we have pioneered the development of using artificial intelligence to process and analyze human affects. That's what we do. So I've boiled it down to this simple equation at the bottom here, which I hope makes sense. Affective AI is where we employ the science of affective computing, and we bring it and merge it into the domain of artificial intelligence. In our case, we are using machine-trained models for artificial intelligence. So I'm going to show you what that looks like. I'm going to explain it to you guys. Everything you need to know about how that works. And then you'll feel a lot more empowered when you hear statements like that. So how does Affective AI work? Just exactly how does this work? This combination that I've talked about. Okay? So I'm going to describe our technology, Affective AI, in two parts. There's the part that you see, and then there's the part that is not visible to you. So I'll explain what that means right now. The first part we refer to as the selfie video. And our booth is just out the doors here, and I encourage all of you to come by and try this out for yourselves. You can actually see this happening just out the doors here. What does it mean? What does it have to do with the selfie video? Okay, so let me discuss this. I break this down into what I call the basics and the basis. So the basics refer to the human physiology, the basics of human physiology. And those basics are simply this. We all have a heart that's beating inside of us. And every time that heart muscle pumps, it ejects fresh blood through the body. When I say fresh blood, I mean oxygenated blood. And that's happening all the time. I've talked to so many people, and I've come to realize that a lot of people, for example, think that the blood flow in the human body just runs in a continuous loop, just running like your garden hose, essentially. That's actually not how the blood flow in the body works. The heart muscle pumps the blood in what we know as the heartbeat. So it pumps it one beat at a time. So if you could actually see, if you could see your blood flow, it would not be a continuous flow of fluid like when you turn on the tap. You would actually see that it's moving in bursts. It moves with each heartbeat. Just like the waves on the beach, for example. Ebb and flow of the waves. That's exactly how the blood pumps inside the human body, anywhere and everywhere, and with all humans. This is the basics, physiological basic behind what we do. This is why this applies to every living primate. So the fact that that blood is being pumped in bursts, well, it turns out that when the blood reaches your face, and it's freshly oxygenated blood, so as soon as the blood comes out, that blood is, let's say, bright red, okay? Medically speaking, that's freshly oxygenated blood. So for an instant, just an instant, right after your heart muscle contracts and pushes out the fresh blood, for an instant, the coloration in your face darkens. It becomes brighter red. And it doesn't matter about your skin tone, your complexion. Everyone experiences a change in the coloration with each heartbeat, just like the wave on the beach. Bright red, not so bright. Bright red, not so bright. Bright red, not so bright. So what does this have to do with anything? Well, I'm going to give you this example, which I think we can all relate to. I think we've all seen at one point or another where someone is very embarrassed by something and they flush, the face goes beet red, bright red, and you think, that person's embarrassed by something. That is an exaggerated example of the human eye seeing facial blood flow. That's why the person's face goes bright red. You're actually seeing, as the vasculature in the face dilates, you're seeing the effect of blood being pumped to the face. So, knowing that there are situations where even the human eye can see the blood flow in the face, I hope you can make that stretch to see that with any modern day camera today, we can also see those subtle color changes that are occurring with every heartbeat. Every heartbeat. That's referred to as the cardiac pulse wave. The cardiac pulse wave. So now that you understand that your face is changing color with each ejection of fresh blood from the heart, that's the basics, the physiological basics of what we're doing. So the next step is, how do we capture that in a meaningful way? How do we sample that? Well, we use a very old principle. It's over 100 years old, called photoplasmography. It's another mouthful, typically shortened to be called PPG. PPG. If you watch any hospital movies, medical movies, or you've been to the hospital, you notice that you'll see at some point where they can take a clamp and they'll put the clamp on your finger, for example, or they might attach it to your earlobe. Any vascular surface of the body will work. They can put it on your elbow. But the purpose of that clamp, that PPG clamp in the hospital, it's actually measuring those color changes that are occurring in your body. That's how your pulse oximeter or that medical equipment actually can count your heartbeats and see your heartbeats. It's the same principle. It's actually looking at the subtle changes of the skin color that occur with every beat of the heart. Now that covers number 1, number 2. Number 3, the skin changes I've explained. Here is where we bring our technology to this, human basics. So the basis of what we do is we extract that color change information from the body. We extract that color change information from the skin. We use a camera to do that. Now, you'll see that there's a video associated with our technology, and everyone's first thought of a video is that I'm on video, you have a video of me, there's an image of me, a video of me. And sometimes it's difficult to convince everyone. Our technology is actually not looking at the image of your face. It's not looking at the image. We actually analyze those video images dynamically to extract the color change information. The change of the color on your face is very rich information. And we've spent years figuring out how to use this information. That's the basis of how we extract blood flow from the face. We refer to that as transdermal. Trans meaning the light is through, dermal, the dermis, through the skin. Transdermal, optical, because it's an optical process. It's not magic. It looks like magic, but it's not. It's physics. Transdermal optical imaging. Imaging means we're pulling the information out. Just like X-rays, MRI, CAT scan, they're all forms of imaging. What we are doing is we are imaging your blood flow from your face. That's the basis of what we do with our tech. This whole process basically amounts to, it's very convenient, terrible, but convenient, that we've just gone through that COVID pandemic. And I know everyone in here has had a nasal swab done many times. The purpose of that nasal swab is so that you could take away a sample of the nasal mucus. In our case, we are also taking a sample. What are we sampling? We're sampling your blood flow. How are we sampling your blood flow? We're using a camera focused on your face to sample your blood flow. That's the part that you see. Part 1, the selfie video. Now, the part that you don't see, even with conventional medical, clinical lab work, you'll donate blood, you pinprick, whatever it is, but you don't see what happens to your vial of blood after that. So it's similar to us. Once we've extracted that blood flow, where's the magic? Everything I've described to you is physics. Where's the magic? So the magic, as it is how we apply artificial intelligence to those samples that we've extracted. Remember, the samples we've extracted is your blood flow. So the second part of our solution exists as computational models. Basically, this is just, again, word speak for machine-trained models. We have a team, a world-class, leading-edge team of researchers, scientists, and engineers. And we have developed, through the process of machine training, custom models that interpret, that analyze your blood flow sample. So we're getting close to 100 unique models that we have purposely trained to analyze your blood flow sample. Those models are on the back end of our system. We put those in the cloud. And we have multiple clouds that cover the globe, multiple locations that cover the globe. For mundane issues like, regional location, all these other things, latency, performance. So we've distributed a network of processors across the globe. That's the back end of our tech. That's the part that you don't see. When you try our stuff later, which I again encourage all of you to try, someone asked me, how long does it take before they tried it? They thought maybe you send it away and come back and get the results. You'll see you're going to get the results in 10 seconds. So I actually have a dashboard where I monitor how long it takes. In Hong Kong, the average return time is 6 seconds. So within 6 seconds, your blood flow will be sent to our cloud, processed, analyzed, run through our computational models, and return a result to you. Okay, hopefully you're with me. So what can Affective AI do for you? All right, let's go on a journey now. Let's go on a journey. What if you could manage the 4 major chronic diseases impacting world health today? I'm talking about stress, cardiovascular disease, hypertension, and diabetes. What if you could help to manage that? Well, are we a medical service? No. But all management of medical anything, all of it, starts with awareness. And most of us are walking around basically unaware of our medical, of our state of health. We're trying to improve that, and that's the number one goal of Neurologics, is to improve awareness of everyone's health. Through our application, we're very passionate about it. We could bring awareness. That's the first step towards managing any disease. So, what if you could do all of that using a smartphone in just 30 seconds? A smartphone application in under 30 seconds. Again, I'm going to keep saying, I'm sure you can tell, I'm not a marketer. I'm an electrical engineer by training. So, I can tell you about what we do. Maybe I'm not as eloquent as some of the other marketers here, but the point is, imagine if you had the power that I just showed you in an app that you could carry with you, you could walk around with you. Well, in 2019, we unveiled this app. It's called Anura. The first place we showed it was at CES 2019 in Shanghai. And we were overwhelmed. We could not believe the response. So before I forget to tell you, that app is available for you to download. All right? The Google Play Store, Apple App Store. You won't get all of the results that we have available. I told you we have almost 100. It's a subset of the results. We call it Anura Lite. But you can download Anura, and everything I just described to you, the camera, the capture, the cloud, you'll see it in operation. More than that, guys, you will have that app, and you can use that to monitor and become aware of your own health. That's Anura. Anura provides 30 plus parameters in under 30, well, it takes 30 seconds for the scan, and I told you 6 to 10 seconds to get the results back. The point being, you can use this all the time, and we encourage you to use it often, because how else are you going to become aware? How else are you going to become aware of your health? Health is not static. Health is not static. Health changes. Health evolves. It gets better, it gets worse. So wouldn't you like to be able to stay on top of that? Our technology allows you to do that, and the first demonstration of that we made available as a personal app called Anura. Anura has been a game changer in the field of digital tech. Health tech. These are actually screenshots from the Anura, and you'll see all the parameters mentioned there: your pulse rate, your breathing rate, your blood pressure. Your blood pressure. In 2019, I think, the same year, we received a patent from the US Patent Office, the world's first non-contact method of measuring blood pressure. I think everyone's had your blood pressure measured at some point. You put a cuff on, you pump it up, you get inflation. How the heck can you measure that non-contact? Okay, try Anura. So, blood pressure, cardiovascular disease risks. Now this is where cardiovascular disease risks, heart attack risk, stroke risk factors is something that we've been doing for the last 3 years. Not just absolute measurements, but risk factors. We're able to predict risk. So with cardiovascular disease risk, CVD risk, heart attack risk, stroke risk, there are risk prediction models that have been around for quite some time. The Framingham model, quite some time. I mean, maybe 40 years now. We initially started using the same Framingham model. So we would sample your blood flow. We created a computational model that would analyze and process that blood flow and give you your cardiovascular disease risk, right? I'm trying to put this in a way that it makes sense for everyone. You see how tangible it is. It's very real. What if you could conduct population health studies, improve health equity at a fraction of today's cost? We're working with quite a few companies that are trying to do this, reaching remote areas, underserved populations, large sample size at a fraction of today's cost. Why is that possible? Why is that possible? This is what it would look like at scale. This is the answer. This is why. It's because that technology can be deployed on a smartphone. Ubiquitous technology, cheaper, quicker, easier, able to access large groups. You know, I struggle a little bit with the wording on this bullet here. It says, of the 20% most poor households. So the globally most poor households, globally, the poorest households, the lowest 20% of them, 70% of those have access to a cell phone. Even the lowest 20% of the population, 70% of them carry a cell phone, have access to a cell phone. This statistic is out of date now. It comes from the World Bank report in 2016. I am sure that penetration is even higher. Basically, everyone has cell phones. And that's why you can reach people with technology like this. We're not talking about have to come into to a lab or ship you a device to measure your blood pressure. Just an app at scale. And by the way, we are in the middle of several of these population health studies everywhere. And it's going to change how we see health, digital health. Imagine if your doctor could measure your vitals and access your health during a video consultation, right? Once again, thanks to COVID, many of us have had online video consultations, right, with your doctor-patient. What if on that call, on that conversation, the doctor could measure the patient, regardless of where the patient is? Why not? The patient's sitting in front of a camera, and there's a compute device that the patient has, either a cell phone or they have a laptop or a desktop. All the elements are there. No contract, no travel costs, no travel risks. I'm here to tell you, in January of this year, 2023, CES, Vegas, we unveiled that product. We unveiled that product. It's called Anura Telehealth.
Getting a live feed of your vitals. I can see your systolic, diastolic blood pressure as we speak. So over the next 2 minutes, there'll be a scan. We'll let this run, and it'll do some analysis, not only for your vitals, but we'll see some other parameters come up in a sec. This is incredible for me as a family doc times 30 years. One of the challenges in COVID, we were really restricted in being able to engage with our patients. I was locked up in my office, they were locked up at home. Really, what sort of interactions could we have aside from a video call? Now we can layer in the ability to reach into the screen and capture some very significant data and measure.
Okay, what you saw was an actual console of a consultation between a doctor and a patient. That doctor happens to be your chief medical officer. He has his own private practice. He's a legit doctor, and he uses that tool.
And we'll just scroll up for a sec and see
what I want to show you here, in addition to live charting, you notice those charts.
Excellent. So again, vital signs you can see, and those were real measurements. So this is a summary of that 2-minute scan. Your blood pressure is amazing.
All right, sorry guys, I'm going to speed up. I'm running out of time. But basically, that's a dashboard showing you live charting of results happening at the same time as the call. Okay, what if there was a smart mirror? A mirror, smart mirror, that could assess people's health risks when they walked into your office. Easy to use, no contact. Well, I'm here to tell you, we have such a device, a Anura magic mirror. And we actually brought one. It's just in our booth out the doors here. You can try it for yourself. A Anura magic mirror. It's the same technology, doing the same thing your app would do, the same thing the video conference thing will do, but you could see when it's applied in a different form factor how it's useful. You're seeing a sneak preview. We're going to be debuting this in January, in a month, in Vegas, CES 2024. I'll let this video run just so you see, for those of you that don't show up, this is what it does. So what you're seeing is the camera on this magic mirror, which is nothing more than an Android tablet. Android tablet. It's not magic, just an Android tablet. What we're doing is we're using the camera, we're scanning his face, we're pulling his blood flow and sending it to the cloud and processing the results and returning them. There's that 10-second delay I was talking about. And then we have a handful of results. Okay, I'm running out of time, guys, but because I want to leave some time for you to ask questions, okay? So, should we do that? No? Okay. So I was going to say, what if you could increase customer engagement, right? This is the application to the insurance industry. Customer engagement. So we use both customer member engagement. We do this with several other, corporate health, several other applications like that, as well as dynamic underwriting. I know this is one of the holy grails. So, because this can also be applied over web, using a webcam. webcam. There's no download. Okay. All right. I think I'm over, guys. That's it. Thank you.